Hi, my name is Andrew McLaren, and I'm going to help you understand logs and negative logs. And to do that, we're going to be looking at some simple problems. We're going to be focusing on just like the whole number exponents, but helping you understand what's going on with like -2 or -5 as an exponent and relating that to logs. So if we look at a number like 1000 and I log that, or if I do the same thing but I'm logging 100 or logging 10, then you're probably feeling like you know how to do that in general. Like this is 10 up to the third power, so this is going to be log 3. This is 10 up to the second power, so that's 2. And this is 10 up to that first power, so this is 1. So we can continue this trend with 1 and 1/10 and 1/100th and help you just see like the pattern of this. So 10 up to the 0th power is going to just be a value of 1. So that's going to be 0 when we log that. And then we're going to have -1 and -2. Now, the best way to help you see this relationship, in my opinion, is to think back to our exponent rules. Like if I have 10 a and I divide that by 10b, or if I have 10a and I multiply that by 10 up to the b, you may recall that these rules, you'll add up the exponents or subtract them. And this will help you kind of see what's going on with these logs as well, and this negative log. So if I had, let's say, like 10 up to the third power, which is 1000, and I times that by 10 up to the first power, then I'm going to get like 10 up to the third plus 10 up to the first power, which is 10 up to the fourth power. In other words, this is 10,000. I can also do the same sort of thing here, where if I have 1000 and I divide that by 100, that's going to be the same as having 10 up to that third power divided by 10 up to that second power. And you can see that that would be 10 up to 3 minus 2, which is 10 up to that first power, which is just 10. So you can kind of see like, oh yeah, if I've got 1000, I divide that into 100 groups, then I get 10 in each group. So when we're working with these positive values, like this kind of makes sense. But what you're going to want to think about is like, well, what if I have like 10 up to that second power, and I times that by 10 up to the negative second power. Now this is just 10 up to the second power is 100, timesing by that by 1 over 100. And you can just see when I do that I get 1. It's like 100 over 100. So in other words, we have 10 up to the second power, and we're adding a -2 to that. And we get 10 up to the 0th power. And remember, 10 up to that 0 power is 1. So you can kind of see that this is important for those, like understanding the negative numbers. Because when we're trying to think about exponents as positive and negatives, it helps you to see them in relationship to these exponent rules. So we can do a ton of more examples. I'm just going to kind of help you see this in a couple different contexts. So if I had, let's say 100, and I divided that by 1/10. Now we could think about this as 10 up to that second power, and I'm dividing by 10 up to that -1 power, which we can see as 10 up to the second minus a -1, or 10 up to the third power. So this ends up being 1000. I'm gonna bring in Common Core for a second here. So if we're talking about in the context of this, if I have like a ton of blocks, like 100 of these blocks, and I split them into like 10 pieces each, then I've got a larger number. So I'm dividing by a fraction, so I've got a larger number here. So it ends up making sense that we end up getting a larger value when we're dividing this by tenths. It would be like saying you've got $100, and if you wanted to divide that into 100 groups, you get one whole each. But let's say you're asking how many dimes you have. Now you've got 1,000 dimes. That would be equivalent to $100. So the same sort of thinking applies in this type of situation. And you can do this with like a ton of different numbers. So we can also look at this with like, let's say we're talking about 10 up to the second power, and we're timesing that by 10 up to the negative first power. If we were thinking about that, we've got, what is that, 100 times 1/10, which we can also think about this in this context where it's like 2 plus a negative 1, which should be 10 up to that first power. So we end up getting 10. And you can kind of see that with the 100 over 10 ends up simplifying down to 10. So if we're trying to think about these exponent rules, these negative numbers need to be going into the denominator because they end up making the exponents smaller. And you can do this with like even another value. Let's say that we've got 10 up to the 0th power, and we're dividing that by 10 up to the second power. So we could think about that as 10 up to the 0th power minus 2, aka 10 up to that negative second power, which you can see is 1 divided by 100, which is going to be 1 over 100. So there's a ton of different ways that we can do this with example problems, but just kind of practicing your like tens, hundreds, thousands, and relating them to the negative values and these operations, in my opinion, is probably one of the best things that you can do, building familiarity with logarithms and negative logarithms. We are talking about in this context log 10, just to keep things relatively simple. You can do other logs, but I think for this type of thinking, just focusing on that log 10 really helps people see the general idea, and then you can apply it to like natural logs as well as logs of other values like log 5 or log 7 or whatever. But if you're not used to thinking in like different number systems, like that's kind of a bit weird. So we're gonna just start with like log 10. I do have a separate video that I've got that goes over how to use these exponent rules also with like pH and POH. So I'm gonna have that on the channel as well. It's a very useful thing to be able to think about your exponent rules and how they relate to your concentrations with acids and bases in solution, and relating these ions to each other. So it's the same sort of tricks with that timesing and up these exponents to get this larger exponent. So I just wanted to kind of plug that in because you're probably working on some chemistry problems where they're working with logs as well, and this trick could be useful.